In this video, I'm going to show you how you can fly around with a jetpack in virtual reality. What you're seeing here is the current state of the project, which is a bit more advanced, but everything else is pretty much the same. If you're interested in how to make those mountains in Blender and take it to Unity, do the light baking and all of that, just leave a comment below. I'm using the Universal Render Pipeline template I started with last time. And for the VR integration, I'm going to go with the Oculus integration. It's an asset that you can find on the asset store for free, so just add it to your assets. I'm also going to drop a link in the description. Then once you have it to your assets, you go into Unity, you say Window, Package Manager, and here on the top you have to choose My Assets. And then really all you have to do is install it. It's going to ask you a bunch of things like, do you want to update this and that, and just choose yes. And also I think there's a tiny bug because it's always going to say import even though you're done importing. So don't worry about that, just continue with it and okay. So the next thing we need to go into Edit and Project Settings. And here we have the XR plugin management and just install the management. And when that is done, it's very important that you go under the desktop and choose Oculus. When you click it the first time, it's going to install some stuff. Then you also have to make sure that your Quest 2 heads-up is in developer mode. Just Google it. I mean, there are a bunch of videos on that topic, so I'm not going to go through that in here. So once you've done that and then you're in Unity, every time you hit play, you can put on your headset and you're gonna see, you're gonna be in the scene. So right now there's only the main camera, so that would be our only camera and it just doesn't really make much sense. But the good thing is that with the Oculus integration package we just imported, we can search for a prefab called OVR player controller. Just grab it, drag it into the scene. And now when you hit play, you're gonna have like this camera rig. So this actually reads the input from the headset and moves, so you can look around. Now there's one more tiny thing we have to do, and that is enable post-processing on the virtual reality camera. So the one that's going to get used in this prefab is the center eye anchor. So we have this camera component here and we have to check post-processing. And then we also have to check HDR, so the high dynamic range colors, and we're going to say use pipeline settings, and now we're going to get this bloom effect. And I think a really good way when you get started with Quest 2 development is you go into the sample scenes under core. There's custom hands folder and you drag in those hands and you just see how they work, and then basically you make a copy, in our case the jetpack hands, and you make a new script and you just like take out a few things that you can use. And so yeah, this is exactly what we're going to do. So for demonstration purposes I'm going to drag in the hands and I'm just gonna go custom hand left, and in here I have the left hand anchor. Drop them in here. So if you click the custom hand left and then the hand script, just double click it. We can just poke around a bit, see how things are done. And one thing that you're gonna see pop up quite a bit is this OVR input, and you can just choose it and hit F12 and then you're gonna jump to this class. And you see it's a static class and it has a bunch of enums and methods. And so this is like the class that knows about the input. And so when you have the hand, what you can do is you can call this a static method. So for example here, this is getting called an update, and it checks how much we are pressing the trigger and then sets the animator. So that's like how much are we grabbing when we are pressing that trigger on the side of the Quest controller. So to do that is we use this OVR input, this static class, and use a method called get. And then we're going to pass in OVR input.access1d. And if you're wondering what that is, once again, select it, hit F12, And you're gonna go there and then you see, okay, it's an enum. It's an enum defined in this class. And access 1D, that's of course all the kind of like the triggers. So we have the buttons, they can be pressed or they can be not pressed. So when we check, hey, is a button pressed, what we get back is a bool. Then we have the access 1D. That means, so we got any value from 0 to 1. So think of it like a slider, because you can press this just slightly or like fully in. And then of course we have 2D. Those are the thumbsticks, like top, left, right, top, bottom. That's it. And anything in between. So we have 2 axes. And so then we have this method. Let's see, we had the hand here. So we call it and we pass that one in. And we're also going to pass in this field, which is which kind of controller are we using. And once again, F12, we can see it's a serialized field in this class. Private OVR input controller, once again, F12, and it's an enum. And you can see one of the enums is L touch and R touch, and that represents the Oculus touch controller, and that's the one we want. And it's serialized, so you can set it in the inspector, and this is of course what they have already done before. So this is the field, this M controller, and it's set to L touch. And I think in here they are just setting it to none, so we don't get an error message when we try to call this get method. So talking about this get method, so we have the float, we are saving it in a field, passing in the axis we're checking and which controller we're checking, and it's gonna return that. And in case you're wondering why there are so many like get methods, the answer is it's overloading. So you can have a method with the same name, like multiple methods, they all have the same name, as long as the parameters are different. And then when you call that method from anywhere, it just knows which one to pick based on the parameters you put in. Right, so hand 1, we're putting in this kind of enum, the access 1D enum and the controller type. And there's only one get method in the input that takes those 2 parameters. So you also have like the raw access 1D, resolved access 1D, and then of course access 2D. So if you were to call like with those parameters, it would get to this method, of course. And so you get a vector 2 back. Actually, let's set up the player controller the way I did when testing this out. So we have the, let's see, we have the Jetpack. I'm going to remove the thrust controller, which I think was sitting here, because the thrust controller from now on is going to sit on the player controller. So what I'm doing is I'm reading both inputs from the Jetpack and I combine that into one force, and so then this one combines those forces and applies it to a rigid body. So this is no longer done by every Jetpack on its own. So I just remove the component. Then I'm going to drag the Jetpack onto the left hand anchor. I'm going to set the Y and Z to 0. And of course then I'm going to see this is way too big. And I've played around with it before, and I think a good value was actually minus 0.6 for the scale. Unfortunately, I'm going to have to do that for the particle systems too. So the fire and the smoke, 0.06, 0.06, 0.06. And then I'm also going to remove the rigid body from this. This is no longer going to have its own physics. So we can just remove that. No need for sphere collider. Actually, this Jetpack right now is oriented for the right hand. So if you want this for the left hand, all we have to do is change the scale to a negative. And of course, once we have this set up and duplicated for the right hand, we're gonna remove this negative. And now this is probably not in the correct spot by default. So what I do is I drag in the custom hand, drag in the Jetpack, make sure this is also a child of the anchor. Then I hit play mode and then I just move it with the transform component. Once the hands are perfectly overlapping, right click the transform, say copy, and choose component. Then I go out of play mode, right click, and say paste, and then I say component values. So that way I just have to switch back between Unity and virtual reality just to get it right, and then you got those values. Unfortunately, you have to do the same with the right hand too. And then once you have that, you can delete the custom hand. It's actually quite important because it might interfere with our own controls. So just select the hand, delete it, and now all we have is this jetpack. But it should be in the right spot. And okay, let's add the scripts. So the jetpack is now going to have the jetpack input script. Let's see, 1 second, scripts, jetpack input, just drag that on here. And the OBR player controller, that's the one that's going to get our thrust controller. And make sure to at least uncheck character controller, because that's just going to keep you grounded. Personally, I'm just not a fan of this anyway, because you can't edit the script. So it's whatever Unity decided your character is going to behave, that's what it's like. Might be useful for like really quick prototyping or like first steps, but obviously when you do something like this, you got to make your own solutions. So we have the thrust controller. We can disable this for a moment, because let's take a look at the jetpack input first. The script is responsible for reading the input, rotating the engine and the fan, and then sending out the new thrust, and this is going to get read by the thrust controller. So let's go through this slowly. Here we have the serialized field for the type of controller. That's just what we had with the official hand. So we can say like R touch or L touch. So when we call the input, we can pass that in and it knows, oh, which controller do we actually want to know the input from. And then for now important is current thrust input. That's a private float. And you know what? Let me show you the how to rotate the engine first, because that's slightly easier. So just like before, we have the transform of the engine and the fan. We just assign this in the inspector. And this line here, so we call this OBR input. Once again, it's a static class, so we can just use the class name and then get. We don't need a reference to it. Actually, it's not even in the scene. So OBR input, and then we say get. This time we're passing in an enum of this type button, and of course the controller. So button means, and if I now click get, and once again F12, and the cool thing is it actually takes me to the one method that's getting called based on the parameters we were passing in. So we also have this get method. This one returns a bool. It asks for a button, which, as you may have guessed, is an enum, and it corresponds to the certain buttons on the controller. So we are interested in 1 and 2. I think those are the two I want to use to rotate the engine. So we have this one, we just ask it. So if button 1 is pressed down, then we're going to rotate the engine. Just like before, engine.rotate, pass in the rotation speed, time.delta time. And then we do the same with button 2. So this is really it. And the fan, we're just going to rotate on the fan rotation speed like we did before. We're going to get to that in a second. And of course, we also want to know the input of our trigger. So we have a float called new input, and we assign it the return value of the OBR input.get, and now we're passing in an axis 1D, the primary hand trigger, so that's this thing on the side, and of course left or right controller. And if you hit F12 here, get, now of course you see this one returns a float. So 0 means you're not pressing, 1 means you're pressing it all the way down. And then we check if this new input is not the same as the last input. I just did that to maybe call this method a little bit less. So if it's not the same, then we're gonna call this method called thrust input changed, and we pass in whatever new input is. So the value 0 to 1. Then we have the thrust input change. And first of all, we save this in a field. So for the next time, the next update frame, we check if it's still the same. We don't need to do all those changes. And then we have the current thrust. That is a vector 3. And we assign it the new input times engine dot forward. So this is the blue Z arrow that the engine is pointing towards. So this way, if we rotate it or if we rotate our arms, either way, whatever the engine is pointing downwards, like that's where the thrust is coming from. And as you might notice, I'm not really using any kind of modifier. So this is always going to give me some pretty low value. But the multiplication, or where I get to play around with the force, that's going to happen in the thrust controller. Right now, it's more important like what is the direction and what is the input. And of course, those are the two things I got in here. And while we're at it, we're also setting the current fan rotation speed. On a side note, that is old, no need for that. So we're also setting the current fan rotation speed every time we change that. And of course, we use the input times max and then the 1 minus input times minimum. You might remember from the last tutorial we're doing this, so there's always some rotation, and we just want to find how much are we between the minimum speed and the maximum speed. And then we're sending out two events, input changed and thrust changed. So those events are here. They are not static, meaning if someone wants to listen to it, they need a reference to an instance of this script. So the first one, thrust changed, sends out the vector 3 that we just calculated, rotation times input. The other one sends out a float and just says the input changed, and we're doing that for our particle controller. Before we were listening to the thrust controller, but now of course every particle controller is connected to a jetpack. So every jetpack has one for fire and one for smoke. So now we have a field called jetpack input. And so based on that, we are setting the speed of the particles, the position of the smoke, and how many particles we are spawning. And here we don't need to know what the actual thrust, the actual force is going to be. We just want to know, okay, 0 is, we're going to use the minimum. And I mean, I think I covered all of that pretty extensively in the last tutorial, so if you're interested in that, check that out. And the other event that gets sent out, the current thrust, that is of course getting read by our thrust controller. So this script is now sitting on the body, so to speak, on just the camera, this whole prefab. We have a private vector 3, current force. We don't need that anymore. Then we have two serialized fields, one for each jetpack. Maybe you could make a list, but I was quite certain I was going to use 2 jetpacks, not 1, not 3. It's gonna stay 2. So just make 2 fields. And I have a rigid body that's gonna get attached to the same game object. Then I have the max velocity, just like before. And I also have this float at force multi, but we'll get to that in a moment. So in on-enable, I want to subscribe to both Jetpack input scripts to the event thrust changed. So every time that gets changed, I want to call this method called changed force, which takes a vector 3, which of course fits perfectly with the Jetpack sending out a vector 3. And in here, I'm going to use the current force. So I made this a public vector 3 read only. There's a confusingly called current thrust, which should be called current force. So it's a private current force that's only getting set by this script. But if any other script wants to at least know what the value is, it can call this property, so with a capital C, and that's just going to return the current force. So the advantage is you can't set it from outside. And of course, every time we change the thrust input, that's where we set the current force. And in the change force method that I just realized had a little bug in here, we read the force out of Jetpack 1 and Jetpack 2, we add them together, divide them by 2 so we get the average, and then we're going to multiply it with this float here, add force multi. So this way we can just play around. For example, I'm using like 800, so I want like this tiny bit there returning and multiplied with 800, because the current force, just like before in fixed update, we take the rigid body and then we add this current force. And just like last time, we make sure to not go too fast. I'm using like this method to clamp. I'm also using a drag in the game. Actually, you might not need this. You can just play around with drag, but in case you want to have more control through the script, you can just do this. You add the force, then you read the velocity out of it, you clamp every value, and then you set it back. And I think test velocity, as the name suggests, is not needed anymore. Oh, actually, you know what? I want that. Because what I did was I would just fly around a bit and then look in the inspector like, okay, how fast am I actually going in which directions? And I think it's quite useful just to compare. And so I made this field so we can directly see it in the inspector. In on disable, we unsubscribe from the events. That's just the standard practice. Yeah, this is actually all there is for this script. So let's go into Unity and set this up. Okay, so we have the Jetpack. We already have the Jetpack input script on it. We don't need to assign controller right now. Just first of all, let's grab the engine, assign the transform, also assign the fan, and then minimum rotation. I think I had like 180 and then like 800. Engine rotation speed, I think 180, so it takes 2 seconds to rotate the engine in a full circle. And let's call this Jetpack VR and drag this into the prefabs folder. So this is a prefab, and I drag this on the right hand anchor. So first of all, I need to change the scale. Let's see where we have it. Probably not like this. So we move the minus, and they're also not going to be positioned right. So once again, just go into play mode and try to figure out where they are. If you've already deleted the hands, just drag them in again. Once again, they were under Oculus, sample framework, core, custom hands. You have the custom hand right, just drag it in. Go into play mode, find the position of the jetpack, copy the values and paste them in again. I already did that, and it's also a bit complicated to do everything at once, including the recording. So I have this OVR player controller here where I found the values, so I'm just gonna go this the right hand so I can copy component. That really just means all the values, right, instead of choosing one. Then custom Jetpack VR, that's the right one. I'm gonna say paste component values, and I'm gonna do the same for the left hand. Then for the OVR player controller, so we now have the thrust controller on here. Now we need to assign the jetpack, so let's see. Actually, I don't have which one is left or right, doesn't matter at all. Jetpack VR, just make sure to use the different ones. Rigid body, we don't have that yet, so let's add a rigid body. Has mass, drag, definitely gravity. Then we also need a collider. I think a capsule collider is good. It somewhat represents a human. You can also take this whole thing, drag it up a bit, just to make sure we are not like below the plane collider, so we're not just gonna be falling down. Even though that shouldn't matter because we have a jetpack. But yeah, let's see. Then we can assign the thrust. I'm assigning this widget body now. You could of course use get component in the script, but who knows, maybe the widget body is not on the same script. So we got this. Max velocity, I think 100 is good. Add force multi 800. So I tried to find some values that would make it feel not so floaty, but really like fast. When I let go of the thrust, I got like a little bit of energy, but then I start falling quickly. And so I used high mass, let's see, widget body mass 10, drag 0.3, okay. Mass 10, drag 0.3. I'm actually tempted to make like a little game out of this. I think in this case I would actually do this by script just to make sure like those are exactly the values I want. And now the very last thing we have to do is make sure to assign the fields here. So this is the left one, so let's say L touch. Also make sure this is somehow multi-select, so just double check you only have the one or the correct one selected. And on the right hand we're going to say controller, this is going to read from the R touch. And there is one more really important thing if you don't want to throw up, and that is in here on the player controller, the widget body. I'm just freezing all the rotations, meaning I can still turn left and right, but I have to use the joystick. I think there could be a cool solution where you can like kind of control it with the force, but I mean the first few times I tried to just go like freestyle, and yeah, you're gonna throw up because you're just gonna be flying around in like loops, like barrels, like non-stop. And then it was finally time to fly around with this thing. Now of course you always got to check your engines, make sure they can rotate correctly. Then you make a quick hop, see that this works correctly. Just saying like safety first when you fly around with the jetpack, and then you're ready to go and lift off. And yeah, it works quite nicely. It's not perfectly balanced yet. I'm definitely gonna play around with the numbers, but so far it looks quite fun. And you can also just burn your hand, of course. And I've placed some trees around the scene because it really helped with like the sense of speed, the sense of just flying in general. The building just doesn't have enough details or like points of reference. Like if there were cars driving around in the street before the building, you would probably get a much better feeling. But with the trees, yeah, that was quite fun. So I definitely want to add some terrain, so you have like a bit of hills and all of that. And if you made it to this point, thank you very, very much for watching all the way. If you have any questions, feedback, criticism, just drop a comment below the video, and you would really help me out by subscribing to this channel, liking this video, maybe tell all your other VR developer friends about this awesome channel. And yeah, also let me know if you want to see anything special. So I'm gonna do a lot more virtual reality and 3D content in the near future. So just let me know if you have any ideas that you'd like to see. Until then, thank you very much and goodbye.